All right, so today we're talking about introduction to DevOps, and we are Use and Tech, as most of us already know. We are Use and Tech, as most of us already know. So Use and Tech is a platform dedicated to closing the gender gap between women and technology. And we do this through the non-coding courses that we offer at Use and Tech, such as business analysis, data analytics, data governance, product design, product marketing, bioinformatics, cybersecurity, software testing, and a host of others. Our founder was inspired by our own career journey, and of course, by what she saw people doing in the industry. She noticed that there are some people who do not touch a line of code, including herself, and they work in tech. So she decided to get into the industry to show people how this can be done. And she has been doing it since 2020. And we've had tremendous results from since inception, sorry. We've had tremendous results since inception. So the result has been phenomenal, and we are committed to doing more. So we are fully online, and we have trained over 25 countries. We have trained from over 25 countries, which is true. And this has been made possible by the virtue of hands-on training and quality of facilitators who ensures our students get value and also monitor them during interview sessions. Amazingly, we have trained students from various backgrounds, such as stay-at-home moms, undergraduates, and so on and so forth. Usually people who want to relocate. They seem to be our highest audience. So where our students work, we have our students working in these places and more. We're going to be having the updated version by our next webinar. So today we are talking about introduction to DevOps, and our guest today is Mbaoma Chioma Mary. We met Mbaoma sometimes last year, and we were totally blown by what she has achieved so far in her career journey. I don't know if she's going to be sharing a little of herself, how she got into this, but if she's not going to be sharing it, just know that she has achieved a lot within the short period. And about our guest, she's a seasoned DevOps engineer at Victoria Bros and a co-founder of Oma. I hope I don't know if what this is, I don't know if it's Arete or Arete, but I believe you are going to say it properly when you start. So it's an NGO providing tech education to underprivileged children and youth. That's totally awesome. She's passionate about leveraging technology to bridge the educational divide and make learning resources accessible to all. Oma is also a writer who simplifies complex technical concepts for diverse audiences. In her free time, she enjoys anime and reading. You know that she's a very free person. People who watch anime, they're always very cool, because I do watch it too. So I'm going to hand over to Oma now so that we can start properly. And we believe that more persons will join us as we continue. Thank you.
Thank you for that introduction. Hi, everyone. Good evening. My name is Omar. You can call me Omar. It's actually Mboma. And I currently work at Victoria Bros, and I run an NGO called Arts. So it's just I and my friends coming together once in a while to host tech events for children living in underprivileged communities. So we just go there, teach them tech, just to show them that, oh, they have more options in life, and there's a lot more to life than what they are currently exposed to. So today I'll be introducing us to, oh, okay.
Yes, so I want to let you know that I already made you the host, and
Okay.
You can also please turn on your video so that we can see you to better the experience. Yes, thank you.
All right,
Thank
thank
you.
you. Okay, I'll just go ahead, share my screen, and we can start talking. How many of us here are aware of the term DevOps? Either we've heard about it or we've used it to work, or anyhow, just how many of us have heard about that term? Let me look at the charts. Oh, okay, so I assume nobody has heard of the term. Okay. Um, I'm trying to share my screen.
Okay, someone is raising her hand. She wants to answer.
Oh, okay. Yes, please. I did not notice. I'm sorry, I have to restart, like I have to rejoin, but I just gave permission to Zoom to share my screen. I'm so sorry.
All right, so apologies about that. Since she's having technical issues with Zoom, as soon as she gains back access, she's going to start. Sorry, please. All right, so she's back now.
Yeah, I'm so sorry about that. Okay. Yeah, the lady whose hand was up, you can go now.
Yes, I think it was Ellen. Ellen, please, you can speak. Or maybe it was a mistake. Maybe, okay, she's speaking already. She's speaking already.
To respond to your question that who has heard the term DevOps before. I've actually heard of it. I work in an environment where DevOps is being used on a daily basis, but I'm not in the team doing the hands-on. So I just want to acknowledge that I've heard and I've been in an environment where DevOps is being utilized. Developed to operate is kind of an agile process whereby you develop apps on the go. You're able to automate some other processes. You're able to spin up cloud environments to work. So that's just basically what I see them do, but not in depth into it. I just see them do it, and I think I follow what they do sometimes, but that's not my core at the moment. Thank you.
Yeah, thank you for your contribution, Helen. That's actually, well, a part of what DevOps is, and you're actually correct about your observation. So we'll just dive a little bit deeper into the topic. So that's me. Okay, so today's class, we'll just look at an introduction to DevOps. I mean, why would anyone use DevOps and why was it even formed in the first place? Look at some DevOps principles, then we'll look at the pillars of DevOps, the life cycle, some tools which are used, then benefits, and some best practices. And I've also included some resources at the end of the slide for anyone who is interested in learning. I think the organizer has the slides, so yeah, you will be able to get it after the call. So what exactly is DevOps? So I always like to say it's the collaboration or the union of the developers and the operation people. So previously, before the advent of DevOps, it's more like we had people working in silos, and that means so developers write their code, then send it over to the operation people who will test and try to like push it out to the consumers. So that period of developers waiting to get feedback from the operations team. I mean, they may pick up another feature and start working on it. So there's that gap, there's a communication gap between both teams. And then probably after the operations people they have feedback for the developers, it might take a long time before developers can attend to that feedback. So I think DevOps is actually pretty young. I think in like, I can't remember the exact year, but probably like 2018, 19, 15, thereabouts, yeah. That was when DevOps was started, and it just made things easier such that instead of developers having to wait for a long time for the operations people to give them feedback on their code, that if it's breaking in production, if there's a bug somewhere, they instantly get feedback. So a scenario would be, okay, I'm supposed to build a website that shows hello world. And then I write my code in whatever language. Then I push my code to probably GitHub or somewhere. And instantly I get feedback that, oh, okay, maybe I mistakenly wrote hello instead of hello world. So I don't have to wait for like 2 weeks or 3 weeks for another person to tell me, oh, you wrote hello instead of hello world. I instantly get that feedback from a system actually. So why is it significant in today's software development landscape? I think number one is the speed. Companies are now able to push out features faster. And why is that? Because of this immediate feedback that developers get whenever they are building their software. And this happens through your continuous integration development pipelines. That is how you get your feedback. So between building and deploying, you'll be able to see exactly what is happening at each stage. So there's an improved collaboration whereby nobody works in silos, nobody works like independently. We all depend on each other for building successful features. Another thing is enhanced quality and reliability. So with the fact that you are getting immediate feedback from a system, you can be rest assured that, okay, I'm very sure that this product getting to our customers will not break on their devices. And why are you able to say something like that? Because you've been able to test extensively and deploy on a test environment, which closely mirrors what the consumer would see on their end. It's also cost efficient. Why is it cost efficient? I mean, it saves costs by optimizing resource utilization and reducing manual error-prone tasks. So this brings us to talking about infrastructure as code. I mean, before, when companies are like building their infrastructure, that is servers, databases, and all that, they tend to buy computers and keep them in a server room. So if, for example, you open a business today, maybe you are selling cakes, and then maybe in your first 3 months, you just have 20 customers and you're running one server. I mean, 20 customers accessing your website every day is not a lot of load. But then maybe by your second month, third month, you're getting like maybe 50, 100 customers. You then buy an extra server. So now these servers you're buying, maybe you're buying like 64-bit servers, something like that. So now you are actually estimating like, okay, I estimate that having 264 GB servers would serve my consumers. But then what if probably during, let's say, between period of December, January. So December, you notice that, okay, maybe 1,000 people or 10,000 people are coming to my website. Then you buy maybe 10 servers. So these are like actual hardware machines. You keep them in your server room. Then what happens in January, maybe when you have like 500 people coming to your website, the load has reduced, but then you still have those servers sitting in your server room, and you have to like pay for maybe air conditioning and someone to service them so they don't go bad and things like that. But the advent of DevOps has helped businesses to scale, whereby you're buying servers on the cloud. So when you have 1,000 people accessing your website, you can buy like maybe 3, 4, 5, 10, 100 servers. Then when the rush hour is dead, rush hour is down, you can then scale down. That's like reduce the number of servers that you have to maybe 1 or 2. And with this, you're able to properly estimate that, okay, when I ran 100 servers for 5 hours, so maybe that's like maybe $100 or so. Now that it has been reduced to 1 server, I'm going to pay maybe like $20 or so. And yeah, so that is one way that DevOps has helped us to save costs. I'm sorry, I have a delivery I need to pick. I will be right back. Yeah, sorry about that. I had to go pick up a delivery. I'm so sorry. Can anyone hear me?
Yes, please.
Okay. Okay, so I'll just continue from where I stopped. Okay, so another advantage of DevOps is business agility, whereby because you already like know the end result of whatever code your devs are writing, and you're able to better handle your finances in terms of costs to set up your infrastructure, you're better able to build features or maybe expand your business scale to accommodate for new customers. So that helps you to be very agile and also gives you a competitive advantage. Let me go to the next slide. Okay, so what are some of the basic principles of DevOps? So number one is collaboration. The collaboration is very important in the sense that as a DevOps engineer, I have to work side by side with developers. An example can be probably I want to write a I want to containerize an app that a developer is working on, I have to work closely with them. But I mean, sometimes when writing languages, I don't know. Like I used to code in Python, but then I'm working with devs that are writing code in JavaScript, Golang, and what have you. So I need to understand, okay, when you are building or running this code, what are the commands you use? Like, how do you go about it? So by understanding that, I'm able to understand, okay, how can I containerize this application in such a way that, okay, I don't need my customer, or I don't need another person to have to exactly run those commands to build the app from scratch. All they just need to do is pull the image, run it on whichever laptop or whatever operating system, and it gets the same result. And another principle is automation. So the thing is, we want to reduce human error as much as possible. And a way to do that is to program a computer, like automate the steps, basically. So an example can be, okay, probably anytime you're cooking, or maybe anytime you want to maybe bake a cake, you know the measurement, maybe 1 tablespoon of, I don't know, baking soda or something. And okay, as a human being, you're prone to making mistakes in your measurements. I mean, something can happen. Maybe you sneeze while you're measuring the baking soda or something. But then when you have maybe a machine that you program to do that for you, I mean, come rain, come sunshine, it is the commands or the instructions you have given your computer that is going to run for you. So you can be rest assured that no matter what happens, come rain, come sunshine, you tell your computer, okay, 1 + 1 is 2, it's always going to give you 2 whenever you enter 1 + 1. That is something about automation. We don't want to manually run repetitive tasks. So we just write a script that does that for us. And anytime you just want to run the task, you just run your script and the tasks get done. The other thing is feedback loops. So feedback loops are very important also because, I mean, be working on a team, you need to communicate. Maybe I can tell the dev, okay, I was trying to containerize your app, but it kept failing on my end. What do you think might be the problem? Oh, this is the problem. Do you know what is causing it? And then it can be like, oh, okay, did you do this? Did you do that? And then I do that, and I also have to like get back to them. And so we go back and forth until the problem is solved. So that back and forth communication is very important to ensure that your end users are happy. So the next thing we'll look at are the pillars of DevOps. So these are like, what do you need to know to say, oh, I'm a DevOps engineer, or what goes into this thing called DevOps? So number one is cloud, and number two, CI/CD, containerization, infrastructure as code, and observability. So when I talk of cloud, what am I talking about? I'm basically talking about our cloud providers like Amazon, AWS. We have your Microsoft, that's Azure. You have Google Cloud, GCP. I think there's also Oracle Cloud, Alibaba Cloud. So, I mean, the thing is, we don't want people to essentially have physical servers. I mean, some people still choose to have those, but I mean, that's on them. But now we don't want people to mostly have physical servers running somewhere. So we use the cloud. So we deploy everything to the cloud. I mean, it's more cost effective. There's a lot of automation options and all of that. So you need to have knowledge of at least one cloud provider. So either you're proficient in AWS or Azure or whichever one. And then some people also are proficient in like all the cloud providers or the major cloud providers. When you talk of CI/CD, what does that mean? Basically, continuous, oh my God. Continuous, okay, now I forgot what CI/CD means. Okay. Let me scroll back a bit. I think I mentioned it somewhere. Continuous integration and continuous delivery, yes. So what does that mean? So continuous integration basically means that, okay, I want to keep adding more code to the codes that I've written before. without the code I've written before breaking. So, okay, just imagine a scenario whereby you're trying to turn eba or make semolina. You're saying, okay, I have my powder mixed with water, but then I want to keep adding more powder to the mixture I have without the mixture going bad, like without the previous mixture going bad. So that's just like what continuous integration it's like. And what does that entail? It entails having a lot of testing infrastructure in place. Your devs write tests. In your pipeline, you also implement test checkers like PyTest or NPM run tests, those testing tools to ensure that, okay, codes written before are passing and the codes that are newly added don't fail tests, and also don't break the previous codes I've written before. Then the CD part is continuous deployment, some people say is continuous delivery. So what does that mean? It essentially means like, okay, someone is using an app on their phone. So maybe on a game app, I'm using a game app, it's okay, it's fine. But then the developers are like, okay, I want to add a new feature to this app. Maybe before on the app, I could only select one color. But then the devs are like, oh, people have been complaining that they want to change colors. So now I want to give them options to select like more than one color on the app. So I don't necessarily want to tell my users that, okay, stop playing game maybe on Monday. Don't play game on Monday because I want to push a new feature. Instead, what I want to do is push that feature out. Maybe have a few of my end users test the app, but they don't necessarily have to know they're testing the app. They test it, and then I see the response, like, does it break on people's phone? Maybe there's a difference between how the app runs on the iPhone or the Android. I log those information and I take it back to my devs so that they can work on it. So it just basically means I don't want my apps in production to break because I'm adding new features there. So how can I handle that aspect? As one way to do it is have a testing environment also that mirrors what your consumers see on their end. So that way, okay, this particular build doesn't break, so we are good to go. The another thing is containerization. So what that means is, how can I run this application on different operating systems and it wouldn't break? So maybe someone writes a Python application using Windows. So I want to be able to take that same Python application and run it on a Linux machine and it wouldn't break. Run it on a Mac OS machine and it wouldn't break. So you have to containerize it in such a way that, I won't have to necessarily go to Python website, download Python, use pip to install whatever. All I just need to do is just run the container or run the image as a container and I'm good to go. They're talking about infrastructure as code. Imagine this scenario whereby as an early startup, you do things manually. Maybe you buy one database, one server, and you just set everything up by clicking buttons on the UI. I mean, that's okay, that's fine. But then as you scale, you become a bigger company, you get more customers, more requests. You would want to expand your infrastructure to accommodate the new customers coming to your business. And so if you have to configure like maybe, let's say 10 servers, so you wouldn't want to like go to the UI and click, 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 click. You're prone to make errors. So having your infrastructure settings written as code is much easier to manage because first off, you can have something called version control, whereby, maybe in January, when I first started my business, all I needed was one 64 gig RAM server and one database, and I was fine. But then maybe in March, I needed 2 servers because my customers increased. So I just go to my code and then I change the number of servers I need to 2. Then I run my scripts and then I have 2 servers. But then maybe ending of March, customers reduced. So I just go back there, change it back to 1, run my scripts, and I have 1 server left. So now, maybe coming later 2 years, 5 years later, and I want to just maybe increase the size of the servers I'm buying because I can afford it now. I don't need to start thinking, oh, okay, what was the size of the previous server? What was the version? Who was the maker and all of that? All I just need to do is go to my version control and check for the dates. Okay, maybe 5 years ago, July, and then I pick that date. I view that file, and I can say, okay, let me edit this file, and I edit the file, and then I get to change the maker. So the fact that I edited that file does not mean I am change, like I'm exactly like altering the file. It just creates a new version of the information on that file. So maybe that file was my version 2, I'll have a version 3 5 years later. The other thing is observability. So now I have used all the DevOps pillars and the tools. My app is in production. I have like 1 million people using my app or my websites. Now I want to know how many people actually visit my website every day. When people visit my website, does it hang? Is the response slow? Does it give them an error? All those information for me to know how my website is performing or how my app is performing. That is where observability and monitoring comes in. So it's just me providing an insight into my app usage to maybe my boss or my CTO. Yeah. So now this is the DevOps life cycle. So someone will be thinking, how do I even add this DevOps practice to the way I build my apps? So anybody can use DevOps, even if it's a side project or a company that has been existing for a while or a new company, anybody can bring in DevOps to their workflow. So the first stage is, okay, I want to build an app. Okay, good, fine. Or I want to build a feature, good and fine. So what is the first thing we do? You have to plan. Okay, what do we even want to build and all of that information. So in the planning phase, there's some DevOps tools you can use, like your Jira, easy to plan your sprints, assign tasks to people, and all of that. So now then comes the coding stage, whereby your developers actually like write code. So to manage this stage, they can use anything. People can write code with anything, but then you need to manage it with a version control software. So that maybe you come later, 10 years time, you come to that particular application, you're like, okay, 10 years ago, somebody made a change to this application. I want to know what that change is. So you just go to the file, you look at it, and you're like, okay, this is change. So you can choose to maybe edit it. So by editing it, you create a new version and your app is updated. Now comes the build phase. So what happens in the build phase where the code is compiled and transformed into executable artifact? This is for languages like Java, where you have to like build for maybe your, I think in Node, you have to build your code, npm run build, you have your dist folder created. So there's that. So Java uses a tool called Maven to do that. Then you have your tests. So testing is all about quality assurance. Like, okay, if I click on this sign in button, does it actually sign me in, or does it show an error? So a tool you can use for that is I think something like Selenium. That's automated testing. So I mean, you can have a QA tester going to test, but then you can also use tools to test for like more accurate results, and to also like automate all those repeated having to enter details in your testing process. There's something called the release phase, whereby you are preparing your software for deployment to production. So basically, you can always release your software to like a test environment, whereby you're like, okay, let me just control this deployment. So maybe I just release it to a small subset of users or just to a test environment. It's up to you. Now your deploy phase is where it's actually moved to a production environment. So someone can say, oh, release phase can be like a staging environment, whereby, oh, push to staging, everybody test, and then we move to production. So when you deploy to production, it is going to your end users. That means you're already sure that, okay, if I click on the sign in button, it's actually signing me in. Now the operate phase is where you can do all your monitoring and observability while it is in the production environment. You're like, okay, how many people even click on that sign in button? And when they click on the sign in button, what does it show them? Is it 200 or 400 error? Or does it show 500 error? Now your monitoring stage is where you it happens over a longer period of time, where you're like, okay, maybe from January to February, let us see how we even made use of the infrastructure that we've bought. Let's see what logs our system generated. So maybe you notice a trend, like, okay, maybe so from monitoring your metrics and everything, you're like, oh, maybe whenever it's March or August, our traffic is always increased. So you know, okay, whenever it is getting to August period, I need to prepare myself to set up like more servers to accommodate for the traffic that's coming in. Then what is the last? Okay, so that is the last stage. So in summary, every stage is important actually, and they all contribute to the DevOps life cycle. Now, it doesn't mean you must follow the stages like the way it is systematically. I mean, if you are coding and you run into an error, you can always go back to planning to get more clarity before you go back to coding. So it's very flexible and it's not set in stone at all. Okay, now, so these are some of the tools that we can use as in our DevOps life cycle. I make use of some of them. Now, the thing is, most of these tools, they do the same thing. So like Jira, Trello, I mean, for the planning phase, people can use anything they want. Some people even use Azure boards. So can use anything you want. But then the thing is, what I always tell people is, I need you to get really familiar with one tool. So for example, when it comes to maybe something like infrastructure writing infrastructure as code, you have to have knowledge of like one tool. So if you know Terraform very well, it wouldn't be hard for you to use a tool like maybe CloudFormation. So the only difference is these tools are used, like different companies have different tools that they use. So it's different toolkits, the same or similar syntax, but then if you understand how one works, you're able to understand how another tool can be used. Another tool in the same phase, really, how it can be used. So that's just my honest advice to people. And okay, so we're looking at benefit of DevOps: faster delivery, improved quality, reduced cost, increased collaboration, continuous improvement, enhanced security, business agility, and gives you a competitive advantage. So in the aspect of security, there's something called principle of least privilege, whereby everybody is just given just enough permissions as they need to get their work done. So you wouldn't see someone giving a developer admin access. No, everybody just gets the exact permissions that they need to get their job done. So in that way, you are sure of your applications in the cloud being securely guarded. Now, what are some best practices? Always opt for infrastructure as code. I know it can be tempting to just go into your cloud provider, click, click, click. But I mean, for the sake of the future, always insist on infrastructure as code, then automate as much as you can. Then always integrate a CI/CD pipeline into your build process so you can know, okay, where did this break or what happened when someone did XYZ. And now security is not an afterthought. As you're building, as you are doing anything, always have security in front of your mind. Now, what are some challenges to DevOps adoption? Now, most companies hearing about this DevOps thing might have been in existence for a long time. And even if they haven't, they are new companies. Some can be like, oh, having to integrate all these DevOps things, it will take so much time. I don't think I have that. I just want to build, and push to the market. So that is resistance to change, some security concerns, and some cultural shifts. But I need to understand that at first it might look tedious, but we need to do that tedious work so that down the line you don't have to account for like technical debts or suffer like heavy security breaches and all of that. So what are some strategies to overcome challenges? As a DevOps engineer, you need to clearly communicate the benefit of DevOps to your boss or the person who wants to bring in DevOps methodology to the company. The other thing is to implement security measures and best practices throughout the development pipeline. The other thing is to foster a culture of collaboration and shared responsibility. So one thing I personally do is I try to get the devs involved in my DevOps process. So I give them small tasks like, oh, come and write this Docker file, just come and do this, come and do that. But I also ensure that I oversee what they are doing, and then I give them feedback like, okay, this file you wrote, it's good, it works, but next time just do X, Y, Z, that kind of thing. So everyone feels like, oh, okay, I'm a part of this. It's not like someone is coming to just like be lord over us and order us around, but this is a process that I am part of. So in conclusion, I hope we have learned like more, or we understand DevOps better, and returning back to our various places of work, we can bring in these DevOps principles, at least even if you don't bring in everything, at least one way or another, you can bring it into your organization's current workflow. So these are some resources that you can look through if you're interested in learning about DevOps or interested in pursuing a career in the DevOps field. And that brings us to the end of the presentation. So if you have questions, you can ask. Thank you.
Thank you very much, Omar. Thank you so much. Please, does anyone have any question for Omar before we? Okay, Ellen is giving a thumbs up.
Thank you, Helen.
Okay, so someone asks in the chat, do I need to learn a programming language to become a DevOps engineer?
I'll say no, because you need to learn Bash scripting along the line. And then you also need to just understand how or what is happening in the code. Like I said, when I want to write even some of my pipelines or Docker files, I talk to the dev like, okay, how do you build your code? How do you run your code? And they tell me what they do, and I just do it on my system. So you have to understand that, oh, okay, this is what this command means when I run it on their code. So I don't think you exactly need to know how to code. But I mean, it's something you can pursue. It's not a terrible idea to pursue it. So yeah. Okay, I think John has his hand up. I don't know if it's...
Yeah, good evening, everyone. Good evening. Thank you for the presentation. I would like to find out, because I didn't join on time, I just want to find out your years of experience on DevOps and how long, if you transition into DevOps, what were you doing before you transition, and how easy was it for you to transition?
Okay.
That's my question. Thanks.
Yeah, thank you. So okay, let me just say it. I was actually avoiding having to say my whole tech journey. I think it's also answered to Lou's question also. So I started my tech career in like 2017. Yeah, 2017. So I was still in university then, year two. I took a course in computer science. Then I got interested. I joined developer communities. And I got an opportunity to work as a program manager at Microsoft, to intern rather as a program manager at Microsoft. So what was I doing? I was gathering experience even in my dev community. So I was organizing programs and planning events. I also learned coding, Python, HTML, CSS. I learned those also. So I was able to intern as a technical program manager because I knew how to code. So I did that for a bit, and then after that, I went into backend, started learning Flask. I did that for a while. did yes, backend engineering. Then I got internship with Goldman Sachs. But before then, I started working as a technical writer with Wikimedia. I was working on the DevOps team. So I've actually started learning DevOps since like 2018, but it was more of self-taught. So I started speaking with like people that were DevOps engineers already. So they just told me, because then 2018 DevOps was not like really, it wasn't as popular as it was, as it is right now. So it was more of, oh, I knew like one or two people then that were just doing DevOps. And they were like, oh, you don't need to learn Docker, learn this, learn that. And I said, okay. I went to websites, I went to YouTube, I learned, took tutorials, I built projects. So while building projects, I was vocal about it. So I would work on something, write an article on it, publish it, post on my LinkedIn, Twitter, post to developer communities everywhere. So that was just me letting people know that, oh, I am a DevOps engineer, even though I did not have like an official work experience. So I did that for a while. I got a job as a technical writer for a DevOps team. I was actually working with the Kubernetes team. And at that period, I just started learning Kubernetes. So I did the job. I mean, I delivered. Then I moved on to work with Goldman Sachs. I worked as a software engineer there. So crazy thing is I had to learn Java to work there. So did my internship, came back to Nigeria. I still went back to my DevOps training. I saw some opportunities to join boot camps, and I did. I joined the boot camp and I worked hard, and I graduated from the boot camp, got an opportunity to intern at Deimos. So that was last year. My internship with Deimos was last year. Yeah. So that was like my first official DevOps role. Did that and then worked at some startups. And I'm currently working at a startup called Victoria Bros as a DevOps engineer. So if you have to ask me my actual experience with DevOps, I'll say I have like maybe give or take 5 years of like unofficial experience. We're talking about like actual work, like official work experience, I'll say 2 years. So how do you start DevOps without prior experience? I mean, it's something you just have to throw yourself into, because it's more of you need to practice it to know it. So you can join a training. I mean, there are like lots of trainings for DevOps springing up everywhere. So you can join those, or you can pick up either roadmap.sh or Cloud Resume Challenge, or I'll say it first starts with learn to DevOps, learn to cloud.guide. So that has a practical, like, should I say, curriculum you can use to learn how to be a DevOps engineer with a lot of projects, a lot of resources you can use. So it's more of you need to actually do the work and also put yourself out there like, okay, I started learning DevOps, I built this, I built that, collaborate with developers that you know, like, okay, your friend is a front-end engineer. Okay, can I access your app that you built? Let me containerize it and run it, that kind of thing. So you start from there and you rise to the top. I hope you're clear with that. Tolu and John.
Thank you very much. Thank you very much.
You're welcome. You're welcome. Any other question? Okay, no.
I guess that will be all because there's no other question in the chat box. So
Okay.
thank you so much, Enibuko, John, Ife, Mojoy, and Abdulsalam, Tolu, everyone, Genevieve, everyone who joined today. Thank you so much. Thank you, Oma, for accepting our call. Thank you, Peters, Duni, everyone that joined today. Okay, so Aziz is raising his hand. Can you please drop useful links? Okay. Then Mama, you can drop it for me on WhatsApp.
Okay.
And then I would forward it to the group. Then Aziz is raising his hand. I think he has something to say.
Okay, sure. I'm sorry, I can't hear you.
Hello, Aziz, please, we can't hear you.
Yeah, I can hear you now.
Maybe you can type your sim. Okay. Okay. You started.
Can you now?
Yes, I can hear you now.
Okay. So good evening.
Good evening.
So so let's say like you have a client or something that just gave you a VPS and just say, okay, please troubleshoot this for me. You know, a VPS is not something like a code that you say, okay, let me try to see what is wrong or something like that. Like there are a lot of folders and files and services that are running. So how would you like go about troubleshooting or going about seeing, okay, these are the services that is running on this VPS, and okay, this is what is wrong with this application, and this is this and this is this. So how would you go about troubleshooting a VPS?
Okay, thank you. So the first thing I'll do is to ask the client, what exactly happened that made you ask me to troubleshoot? Because I mean, something has to be wrong, or the client should have experienced something for them to ask me to troubleshoot their VPS for them. I think that's a good place to start from. So once you understand that, oh, okay, maybe the problem was it's loading slowly, or my websites are loading slowly, or maybe this memory is full or something. I saw an error message yesterday. Then you know, okay, what exactly am I looking for? Yeah, I don't advise anybody to just blindly go into a system, especially if it's something that someone else has worked on before. So ask your clients what they experienced or what they noticed that made them ask you to come troubleshoot.
Okay. Okay. All right. Thanks.
Hello.
All right, so we are exactly on track. 7, we said it's going to be 6 to 7, and this is 6:55 already. All right, so thanks so much everyone for joining. See you some other time. We have another webinar coming up. You might want to join, positioning yourself for EB1 visa. So we'd like to see you there as well. If you are interested, I'm going to share the link when the time comes. So thank you everyone. Do have a
Can I ask a question?
Okay, sorry. I thought it was from the last question. All right, no problem.
No. I was gonna ask, what's the duration of the course?
Okay, so we are yet to launch it. We are yet to
Okay.
launch the course. Yes. We are yet to launch the course. So when we do launch it, then we are going to announce.
Okay. All right. Thank you very much.
All right. Thank you, sir. Thank you. Good night.
Bye. Take care, everyone.
Good night. Bye.
Bye.